Have you ever wondered about the colorful patterns that appear when light shines on a thin film of oil or a soap bubble? Those mesmerizing patterns are called Newton's rings, named after the renowned physicist Sir Isaac Newton, who first studied these patterns in the 17th century. Newton's rings are a phenomenon that occurs due to the interference of light. When a ray of light falls on a thin film, like oil on water or a soap film, some of it gets reflected off the top surface, while some of it passes through and gets reflected off the bottom surface. Now, these two reflected rays of light can either interfere, constructively amplifying each other, or destructively cancelling each other out. The constructive interference creates bright spots, while destructive interference results in dark spots. Together, they form a pattern of colorful rings, hence the name Newton's rings. The colors and their intensity depend on the thickness of the film and the wavelength of the incident light. The concept of Newton's rings is not just fascinating trivia. It's fundamental to understanding how light behaves and interacts with different mediums. It's been pivotal in developing technology like thin film optics used in digital cameras and microscopes, and even in the creation of certain special effects in films. To recap, Newton's rings are a phenomenon that occurs due to the interference of light. When light falls on a thin film, it gets reflected off both the top and bottom surfaces. These reflected rays can interfere constructively or destructively, creating a pattern of colorful rings. The colors and their intensity depend on the thickness of the film and the wavelength of the light. This phenomenon has significant applications in technology and entertainment, making our world a little more colorful and a lot more interesting. So, the next time you see a soap bubble or a thin film of oil reflecting the light, take a moment to appreciate the science behind those beautiful colors. Because in the end, it's all about light, reflection, and interference. Or, as Sir Isaac Newton might have said, it's not magic, it's physics.